Assalamualaikum warahmatullahi wabarakatuh and greetings to all. I am Nur Shazana binti Muhammad Rafi from Malaysia, Japan International Institute of Technology MJIIT, UTM Kuala Lumpur. I am a 4th year student and currently is doing my final year project. This video is one of the requirements needed to succeed in this course. I am from Intelligent Dynamic and System ICOSA. Before I start, I would like to thank to my supervisor, that is Dr. Aminuddin bin Haji Abu, and my co-supervisor, Dr. Nur Azizi bin Uthman, for their invaluable advice, motivation, generous encouragement, persistent and strong support throughout this study, and their faith in my ability to deliver the case study. In addition, I would like to thank to my family and my friends for their support to accomplish this achievement in this final report. As shown is my FYP topic, that is passive noise in air conditioning ducting system. This is the content of my presentation that have 5 chapters in total. Nowadays, there are a lot of big buildings all around the world. Air conditioning will be one of the important parts to be used in any place. In heating, ventilation, and air conditioning ducts, HVAC, are conduits or passages used. The function of the ducts are to deliver and remove air. As example, supply air, return air, and exhaust air need airflows. Ducts are commonly deliver ventilation air as part of the supply air. Air conditioning has many types according to its situation. Small room and office might using split air conditioners, window air conditioners, and more. But for multiplex building, central air conditions system are used. When using central air conditions, ducts are necessary to be installed. In order to provide comfort conditions, cool air from the air conditioning equipment must be adequately delivered to rooms or spaces that are cold. Types of ducts and its impacts can affect human comfort and affect the air distribution inside ducts. By observing its types, sizing, shapes, and more, the duct system can give a proper distribution of cool air. To understand clearly, vibration can be considered as an oscillation or repetitive motion of an object around an equilibrium position. In HVAC industry, without any form of vibration from equipment, sound will not be generated. Even when sound is not present without vibration, human can also notice sort of vibration. Thus, by limiting the vibration produced by mechanical equipment is the best way to reduce sound. The most commonly used duct cross-sections are rectangular, flat oval, and circular in heating, ventilation, and air conditioning HVAC applications. Ducts transport the conditioned air from an air handling unit AHU to an occupied space. Similarly, the sound produced from an AHU propagates to the receiver in longitudinal and transverse direction of the duct. To approach the solution to any specific noise problem, we need to understand the basic principle of acoustic and how noise or unwanted sound is produced, how it propagates, and how it is controlled. Engineers also have to become familiar with the treatments and modifications that can be applied to HVAC system to reduce unwanted noise and vibration. Based on the topic given, which is passive noise in air conditioning ducting system, there are 3 main objectives that needs to be accomplished. 1 is to measure natural frequency of ducting system. Next is to observe dynamic characteristic of the duct system, and last one is to observe natural frequency in different shape of the ducting system. Next is for the problem statement. It is common to have some vibration and noise, even in a properly designed and well-maintained system, because HVAC system involves several moving components. However, excessive noise and vibration created through the ducting system can create an uncomfortable sound for human and also can lead to other performances issues. Only in some situations can vibration be felt directly. When the frequency is low and the amplitude is high, people are more likely to experience vibration. However, negative effect begins before the stage is reached. Many mechanical components, particularly the bearings on rotating machinery, are very susceptible to vibration. Since rotating machinery is one of part that is mostly used, problems with noise and vibration will be affected. Therefore, it is important for the engineer to reduce and limit the sound and vibration made. For literature review, these slides will briefly explain about sound radiation characteristic of rectangular duct. Of all the geometries, rectangular duct has maximum breakout noise at lower frequency, which means minimum wall transmission loss. Breakout noise causes the structural acoustical coupling between the flexible duct wall structure and the acoustic domain inside the duct volume. Airborne and structure-borne sounds contribute to duct breakout noise, which is more dominant at low frequency. The hydrodynamic force and the acoustic pressure wave excite the duct wall and cause structure-borne noise. Galvanized aluminium and stainless steel sheets are 100 times 100 mm up to 2000 times 2000 are manufactured in rectangular ducts and optionally in larger dimension. In low and medium pressure models and versions for smoke extraction systems, rectangular ducting is available. Rectangular ducts pre-insulated inside the mineral wool having a high acoustic and thermal properties are also included in the collection. For circular duct, its shape is the most efficient, which offers the least resistance in conveying moving air. Because it has the greatest cross-sectional area and a minimum contact surface. In other words, it uses less material compared to square or rectangle ducts for the same volume of air handled. For methodology part, firstly, modeling type must be identified. In this case, there are two types of modeling, which is rectangular duct and circular duct. Simulation setup is needed to ensure that the element that is used are consistent. Dimensions of the rectangular shape is 609.6 times 2743.2 times 304.8, while the length of the circular duct is 2743.2. After the dimension has been put, next is to put a constant element for both of the ducts. In this study, aluminium is used. Simulation setup is important as to determine the properties reading is accurately keyed in to avoid any fatal issues. After the simulation setup and simulate two different ducting shapes, data can be obtained. If the simulation satisfies three main objectives, where passive noise is reduced in one of the different ducting systems, then the simulation has succeeded since one of the ducting systems has a reduction of natural frequency. If it is against the objective, then simulation needs to be repeated from collecting data until it reaches the best result. Next is result and discussion. The simulation has been conducted by using Nastran and Patran software with two different parameters. One is by using rectangular ducting system and the other one is by using circular ducting system. Each ducting system shape has been drawn with its dimension. Properties of aluminium is inserted with the same value of elasticity modulus, Poisson ratio, and density in both ducting shape. This is vital to get a specific and accurate value of natural frequency. After running the simulation, we can observe that there is no fatal at the analysis result. Thus, the result can be recorded. Rectangular has shown that its result has the least natural frequency rather than the circular duct. Results of the simulation are recorded as in Figure 1 and Figure 2, and there are three modes are selected to justify which duct shape has a better result. This study is conducted to reduce passive noise in air conditioning ducting system that is used daily in any big buildings. In this case, the main objective were to identify the most efficient ducting system with reduction of noise and vibration when there is an air distribution inside the ductwork. Next is to find the natural frequency for two different ducting shapes. There are more than 9 modes to be obtained. However, only 3 modes are needed to justify which shape of ducting system has the least natural frequency. Circular ducting system mode 1 has a frequency of 14.922 Hz and second is 22.498 Hz and mode number 3 is 23.775 Hz. And for rectangular ducting system, mode 1 has a frequency of 9.665 Hz, mode 2 is 15.177 Hz and mode 3 is 19.027 Hz. Ducting system with the least natural frequency has the least noise and vibration. and rectangular has the least amount of natural frequency. I think that's all from me. Thank you for lending me your ears.